So now let us move into the next type of electronic displacement, that is hyperconjugation. Okay, so we have done conjugation. Now we are moving to hyperconjugation. So let's go for it. So it is hyperconjugation. So we have seen that conjugation is when pi electrons are in interaction with pi electrons. Pi electrons are in interaction with pi electrons, then it is conjugation. Now in hyperconjugation, pi electrons and sigma electrons will be in interaction with each other. So when a CH bond is attached to a multiple bond, attached to an unsaturated system, then what it does is it releases its electrons towards that unsaturated system, and this is what we call as hyperconjugation. Now let us start with an example. So if we have propene, now this is the unsaturated system, okay, carbon-carbon double bond. Now the carbon next to the unsaturated system, if it is having CH bonds, it will release its electrons towards the unsaturated system, and this interaction is known as hyperconjugation. Okay, this is also known as Bakarnathan effect. Bakarnathan effect, because it was given by Bakar and Nathan. Okay, now let's move into understanding this concept in depth. Now we are taking the example of propene. So we are writing it again. Now just open this CH3 and write it. So this is the propene molecule. Now what this CH3 group does, it will release the electrons, the sigma electrons of the CH bond towards the unsaturated system, like this. Here it will go here. Okay, now a symbol here we will be using the same arrow as we use in case of resonance. So now because this hydrogen is not deprived of electron, it will get a positive charge. These two hydrogens are as such. Now here it is a double bond. Now CH, CH2. Now because the pi electron has shifted towards this side, so it will get a negative charge. This carbon will get a negative charge. It will be having two extra electrons with it. Right? Now, if this hydrogen can go into hyperconjugation, this hydrogen and this hydrogen, they can also go into hyperconjugation. So two more structures will be possible, where we will be putting this positive charge on this hydrogen, and this will be having a bond. So just like resonance, we write it. Similarly, the third hydrogen, this one, good. Okay. Now, I think you might not be knowing, or you might be knowing what is an alpha carbon, what is a beta carbon, what is a gamma carbon. So let me just explain that to you. Now, suppose we have this carbon chain, CH3, CH2, CH2, and here is the functional group. Okay. Now, the carbon just next to the functional group is the alpha carbon. Carbon next to the functional group is the alpha carbon. Then next to the alpha carbon is the beta carbon. Next to the beta carbon is the gamma carbon. Now, in this case, when we are talking about propene, the functional group will be the carbon-carbon double bond, because of carbon-carbon double bond, it will be having different properties. Okay. So the carbon which is next to the carbon-carbon double bond will be the alpha carbon. This means this is the alpha carbon. So now the number of hyperconjugating structures possible, it will depend upon the number of alpha hydrogens. Now, if this carbon is alpha carbon, the hydrogens attached to alpha carbon will be known as alpha hydrogens. Hydrogens attached to the beta carbon will be known as beta hydrogens. Then hydrogens attached to the gamma carbon will be known as gamma hydrogens. Okay, so in case of hyperconjugation, we need to see how many alpha hydrogens are there. So the number of hyperconjugating structures will be equal to the number of alpha hydrogens present. Now, in this case, if we see, it seems as if this hydrogen is not bonded to the carbon and it is in the air. Actually, it is having interaction with this carbon. It is not free to move. It is not free to move, but it appears as if it is not having any kind of interaction with carbon. So this hyperconjugation is also known as no bond resonance. No bond resonance, because it seems as if there is no bond between carbon and the hydrogen carrying this positive charge. Right? So this is the concept of hyperconjugation. Now let us see how will it be impacted with the number of hydrogen atoms on the alpha carbon. So let me just clear my screen. Okay. Right. So now suppose we have a carbon-carbon double bond and we have a ethyl group attached to it. Ethyl group is CH3, CH2. This is the ethyl group. Okay, now it is attached here. Now the alpha carbon is this one. It is having two hydrogens. So we have two alpha hydrogens. So the hyperconjugating structures possible here will be, we will be writing the hyperconjugating structures as this. So it will go here, from here to here. CH3C, this is H positive. Okay. Now this is double bond, CH, single bond, CH2 with a negative charge. Cool. Okay. Now the next structure possible is so these two structures will be possible. Now, if we take, here we took the ethyl group. Now we are taking the isopropyl group. So just you need to keep in mind what is ethyl group, what is isopropyl group. Isopropyl group is CH, CH3, CH3. Now, if it is attached to the unsaturated system, so CH, CH2 double bond. So sorry, just let me clear it off. Clearing the screen. Okay. Now when isopropyl group is attached, you can just write it like this. Right? Now, this is the alpha carbon. Now the alpha carbon is having only one hydrogen attached to it. So this will be the hyperconjugating structure. Clear? Then next we can take tertiary butyl structure. Tertiary butyl group. Tertiary butyl group is now this group does not contain any alpha hydrogen when it is attached to C double bond C. So we can write it like this. Okay, now no hyperconjugating structure or no hyperconjugation. Okay, now the various structures which are formed during hyperconjugation, they are known as hyperconjugative structures, hyperconjugative structures, or contributing structures. Good enough. So now we will be moving into the orbital explanation of hyperconjugation and applications of hyperconjugation. So it will be in the next video.